Hi guys, welcome to your section 4 review. At this point you should have already completed your section 4 green sheet and the Chem to Go section. You should also have your section 4 CAMI journal completely finished. Right, so this is a review video that will work best if you're checking your work with this instead of completing your work. Alrighty, so the goal after this is you should be completely ready for the section 4 quiz and ready to take that while you are at home. So before we review anything that we've already done, I want to do a quick warm-up question. All right, so for number one, blank refers to a substance's ability to be shaped with a hammer without breaking. Number two, a substance has a high blank if it returns back to its original shape after being pushed, pulled, twisted, bent, or flattened. Number three, steel is made by adding carbon to hot iron. So part A, is steel a composite material or a pure material? And then why, or for B, why is steel preferable than pure iron? Number four, how would you explain the difference between stretchability and elasticity? All right, very good. So hopefully these questions help to activate your brain a little bit, make you think. Some of these questions may be quite similar to something you might see on the Section 4 quiz. All right, so now I'm going to go over questions 1 and 3 on the Chem to Go green sheets. So it would be wise for you to get your green sheets out as we go over this. So number 1 says a composite material tested bounces half as high as the original material. How can we create another composite that bounces only 1/4 as high? All right, so in this scenario, right, when creating your composite, your bounce actually decreased, and it was decreased by half. So if we wanted to decrease in half again to get down to only 1/4 as high, right, because 1/4 is half of 1/2, then we would need to add even more of our composite material, right? So we would want to double our composite material again in order to get our bounce to decrease in half again, right? So in this scenario, the composite material actually decreased our physical property. While it may have increased other physical properties, are in particular, it decreased the bounce here. Alrighty. For number 3 on your Chem to Go, when road contractors are laying cement, they first place a series of steel rods in a special pattern. Then they pour the cement on the rods and allow it to harden. The composite is called reinforced concrete. You may have seen um, people working on the roads, especially the medians, the concrete medians that you see between lanes of the highway, um, is often reinforced concrete. So, what is the purpose of these steel rods? All right, so hopefully you answered that adding these steel rods increases the strength, the physical property of strength of the concretes. Um, all right, we talked often of how a composite material increases the strength of that material. Um, so in this case, if we want this concrete to stay as strong and durable as possible, we can add these steel rods in a certain pattern, like a pattern you can see on the right here, which would make them stronger, more durable, and last longer. All right, so you should have still answered number 1 and number 4 in your Chem to Go, and at this point, we should be putting our green sheet to the side and opening up our CAMI journal. I'm going to start by going over some of the checking up questions. So we're going to start by describing a situation in which each of the following properties of material might be important, and I want you to explain why that property might be important. So you already should have examples down. If your examples do not match the ones that I go over, that is completely okay because there's almost an unlimited amount of examples for these. Uh, but just in case you were stuck and you couldn't come up with something, we will discuss a couple. So for elasticity, what might be important to be elastic? One thing that comes to mind for me right away is um, the waistband in my sweatpants. So I don't know if you've ever noticed, if you have a very old pair of sweatpants, it kind of loses the elasticity, right, of the waistband. So we want that waistband to be able to stretch out when we put our pants on, but then be able to tighten back up to its original shape, right, when you are wearing them. So um, sweatpants or pajama pants or athletic shorts, these are all perfect examples of elasticity with a fabric. All right. An example where uniformity might be important, right? That might be a very good thing for painting a new wall. So let's say you purchase a new home and you want to repaint all of the walls. It will be important, I'm sure, for your aesthetic purposes, just to make sure that the paint on the walls is uniform throughout, right? You have no spots where there's any old remaining plaster or old paint colors showing, um, and have a nice smooth paint the entire way. So uniformity would definitely be important if you become a painter or want to paint your house someday. An example where strength might be important. I might think about um, maybe a bridge that has to hold some cars over top of water. Right, so we have a very large bridge over the Susquehanna connecting Lancaster to York, right? And at any point in time, there might be over 100 cars on that bridge at one time. And this bridge needs to be strong enough to hold the weight and the force of all of these heavy vehicles. And for bounce, one thing that automatically comes to mind when I think of bounce is a basketball game, right? And how miserable would it be to watch a basketball game if the ball was not bouncy, right? You would either have people rolling the ball up the court, or constantly just passing it because they wouldn't be able to bounce the ball off the ground. Um, and sometimes, and maybe you've played basketball at the park with the ball that's overinflated, right? Having a ball that bounces too much for basketball might not be good as well. You want that perfect middle ground of a ball that bounces but is not too bouncy. All right, so those were some four pretty good examples of these four physical properties. Now remember, yours could have been different, and that is a-okay. All right, and our essential question. So this is at the bottom of the last page of your um, CAMI journal. So we're going to go over this. So first thing, the how do you know? So how would we know whether a solution is homogeneous or heterogeneous? And that's actually not something that you see on your journal, but I think it's a good question to address here. So we can tell that a solution is homogeneous or heterogeneous by whether or not it is uniform throughout. So looking at this picture here, I can see that the cement on the left is homogeneous because it looks like the same color and material the whole way through. But on the right, we can see that the concrete is definitely heterogeneous because we can see it's not uniform throughout. There are different pieces that make up that material. So for the why do you believe, right? And for you guys, it might be, yep, it's why do you believe. So sometimes when roads or driveways are being repaved, the builders choose between cement and concrete. Cement is a mixture of clay, lime, and water used to bind things together. Concrete is cement with sand or rocks mixed in. So question number one asks, how do cement and concrete compare to the clay and composite that we made in lab? So which one of these would you say is similar to our original clay mixture? And then which one of these is similar to our clay composite after we added some materials to it? Very good, right? The cement is definitely similar to the clay mixture that we had, and the concrete, because you can see the different um, pieces of rocks and sand in the concrete, The concrete is definitely similar to our composite material that we had made. So for number 2, builders often choose concrete over cement. Why do you think they might do this? Right, well, we know from our notes on composite materials that adding materials to make a composite increases the strength and durability of the substance. Right? So let's imagine you're paving your driveway with cement. Right? It might not last as long, or be strong enough to withstand, right, the weight of cars going over top of it, and withstanding some erosion as well. While concrete, if you paved your driveway with concrete, it will last longer. Um, it will not take as much damage. It will be stronger than the cement would have been. So there are definitely some advantages to using the composite concrete over the homogeneous cement. All right, so that is it for our section 4 review. Right, make sure that you have all of these things ready, because you will be handing in your section 4 Cami journal next time we see you in class. It is now time to maybe spend some time reviewing your material and hopping over to the section 4 quiz. Good luck. I know you're going to do well.